Hi everyone. These are two examples of Charles' law calculations. Here's the first one. Predict the final volume of 0.500 liters of gas at 15 degrees Celsius when it is at STP. I might find myself diving right in if I feel good about what the question's giving to me, what it's asking me to do, the formula. If everything about it just clicks for me, I might dive right in. On the other hand, I might just slow down and add some labels right into the question just to help with my interpretation, to help me wrap my head around what's going on. Predict the final volume. Oh, the question's asking me to solve for V2. What's V2? Of 0.500 liters of gas. Oh, if I'm looking for V2, this 0.500 liters must be V1. This initial volume of gas is at 15.0 degrees Celsius. That's T1. And now we're going to move to STP. STP, standard temperature and pressure. It goes along with pressure and a temperature and also a molar volume. STP, because this is a Charles' law question, the pressure is constant. What I care about is the temperature at STP. And at STP, the temperature here is 0 degrees Celsius. STP, it's this indirect way of the question letting me know that I have 0 degrees Celsius for my temperature. Once I have that on, I can start to think about the question. Oh, it's V's and T's. It's Charles' law. One of the challenges as we move through the unit is just being able to identify what formula to use. This is V's and T's. It's Charles. Charles' law is V1 over T1 equals V2 over T2. I need to solve for V2, so I need to manipulate this equation. My first step is to cross multiply both sides. Or to say it in another way, I'm going to multiply both sides by T1 and multiply both sides by T2. It's easier to say cross multiply. I cross multiply, and I get V1 T2 V2 T1. Now I need to isolate the V2 variable here. That means I need to divide both sides by T1. Divide by T1, have to do it to both sides. And now these T1s cancel, and it leaves me my formula. V2 equals V1 T2 over T1. Maybe you don't need to show all those steps. Maybe your comfort level is higher than that and you can skip forward. However, if you need to take your time, take your time. V2 equals V1 times T2 over T1. Now I can start to substitute in, but now it's also a matter of personal preference. Are you the kind of person who wants to convert these two temperatures into Kelvin first and then substitute? Or would you do something like me? Check it out. V2 equals V1. What's V1? 0.500 liters. T2. What's T2? Oh, this one. 0 degrees Celsius. So that's 0 plus 273.15 Kelvin. This is divided by T1. What was T1? 15 degrees Celsius. So the Kelvin temperature is going to be 15.0 plus 273.15 Kelvin. You might be the kind of person who wants to do that conversion separately, and so here you're just writing in the actual Kelvin temperature. However, your comfort level with the math might be somewhere where I'm at, and you can write things down like this and work it all out on your calculator. Now I'm pushing buttons. 0.5 times 273.15 divided by 15 plus 273.15. Before I hit enter, let's ask ourselves, is the volume here going to be more or less then 0.50. Well, what happened to the temperature? It went from 15 to 0. The temperature was going down because Charles is a direct relationship. I expect an answer less than 0.5. 0.47397,189. Didn't go down by much. I need to also, this is the raw answer, I need to think about my significant digits and my units. The two numbers in the question both have 3 significant digits. That's the most common thing for us in chem, 3 sig digs. So I need to round off my answer here so that it also has 3 significant digits, which is 0.474. I found the volume. The two volumes have to match. These 2 Kelvin temperatures are going to cancel off. That leaves me liters. The final volume here, V2, 0.474 liters. A second example, going to go a little bit faster. A 2.25 liter container of gas at 20.0 degrees Celsius is heated until the volume expands to 3.15 liters. Determine the final temperature. What's the temperature going to be? Well, the volume went up. If the volume goes up, the temperature has to go up. Charles is a direct relationship. And also, there's the word heated. There's all kinds of connections that we can make to help us give ourselves an idea about what the answer might be. I might feel comfortable diving right in. However, again, it's worth slowing down a little bit to throw some labels in here. 2.25, that's V1. It's at 20 degrees Celsius. That's T1. The volume expands. Notice that word expands makes the logical connection between the 2 volumes. This is V2. And determine the final temperature. We are looking for the second temperature, T2. I might work through my manipulation to arrive at the formula. T2, it's V2 T1 over V1. If you need to take your time to work that out like we did before, that's okay. Do what you need to do to get the answer. Now I'm substituting. V2, make sure I get that correct number in there. V2 is 3.15 liters. T1, it was 20 degrees Celsius. We need to convert that into Kelvin. This is over V1. V1, 2.25 liters. And I got the numbers in, I'm calculating. 3.15 times 293.15 divided by 2.25. Again, 410.41. 410.41. This is the raw answer. It came out in Kelvin. These liters cancel, it comes out in Kelvin. Notice the question doesn't say specifically how I'm supposed to report the temperature. It just says, determine the final temperature. That means I can leave my answer in Kelvin. I do need to be conscious though, there might be times when a question specifically says, what's the temperature in Celsius? If I'm asked to give the temperature in Celsius, then I would have to do a conversion here at the very end. This question doesn't say that, I can leave it in Kelvin. But I do need to think about my significant digits. The 3 numbers in the question have 3 sig digs. Need to round my answer off. 410, we can leave it in Kelvin. When we're working with Charles' law, the manipulations for the formula are slightly more involved than Boyle's. You might want to show those steps. It's really important that we convert temperatures into Kelvin before we do the calculation. We can show the conversion as we do our work, or your personal style might be do that conversion first before you substitute the values in. We have to be conscious of those times when we're finding the temperature. If it's left vague, we can leave it in Kelvin. It's probably easier just to leave it in Kelvin. But be on the lookout for those times when a question specifically says, what's the final temperature in Celsius? Then we would have a little bit more work to do. And I hope that helps.